Now let's just move on further with the theorem. And the theorem number 1 says that if two lines intersect each other, then the vertically opposite angles are equal. We have to prove that the vertically opposite angles are equal. So let us suppose if I'm just talking about the given condition. So we all know about the vertically opposite angle. So let us suppose if I'm just taking the two lines A, B and C, D such that they are intersecting at the point O. So here we can see we have the pair of vertically opposite angles. So let us suppose if I'm just starting with the given condition. The given is the lines A, B and C, D intersecting each other at O point such that they form pairs of vertically opposite angles. So let us suppose if I'm just writing vertically opposite angle as nothing but VOA, which is representing vertically opposite angles, and they are nothing but of the form. You can see vertically opposite angles are AOC and BOD, and the second pair is nothing but AOC and BOD, and the second pair is nothing but AOD and BOC. These are the two pairs of vertically opposite angle. So what we have to prove? We have to prove that angle AOC is equal to the angle BOD, and further we have to prove that the angle AOD is equal to the angle BOC. So we just need to prove this thing. So let's just start with the proof of this one. So for the straight line, CD, let us suppose if I'm just talking about the CD. So we can say that for CD being a straight line, OA is a ray stands on CD. So if OA is a ray which stands on CD, then we know about this particular thing that by the linear pair axiom, the angle AOC plus the angle AOD is nothing but is equal to 180 degree. Why so? By the linear pair axiom, we can say this fact. By the linear pair axiom, if we have a ray that stands on CD, then the sum of their angles is nothing but is equal to 180 degree. So AOC plus AOD is nothing but is equal to 180 degree. Now further, let us suppose if I'm just moving on, if I'm talking about the straight line AB. So for AB being a straight line, OD is a ray stands on AB. So it implies the angle AOD plus the angle DOB is equal to 180 degree again. So we can say this from the linear pair axiom again. So let us suppose if I'm just taking it as the equation number 1, or if I'm taking it as equation number 2, so we can say that from 1 and 2, angle AOC plus angle AOD is equal to the angle AOD plus the angle, let us suppose if I'm writing DOB as BOD is equal to 180 degree. So as you can see, these are equal to each other. So we can compare the two, the sum of the two angles, this and this. So by the comparison, we can see that the angle AOD is actually cancelling out with the angle AOD, and we are actually getting at the end angle AOC is equal to the angle BOD angle AOC is equal to the angle BOD. If I'm just taking these two only, if I'm just taking these two only and neglecting this one, so if I'll compare both of these, so it means that AOD are getting cancelled with each other, and angle AOC is equal to angle BOD, which is actually the thing that we have to prove, that which is actually the thing that we have to prove, that angle AOC is equal to the angle AOC is equal to the angle BOD. And in the similar manner, similarly, we can prove that the angle AOD is actually nothing but is equal to the angle BOC. We can also prove this, that the angle AOD is actually nothing but is equal to BOC using the same concept. And hence at the end, it is proved that the vertically opposite angles are actually equal to each other using the linear pair axiom concept. So this is all about the theorem number 1.